This video is on infinite limits, which should be a partial review of Algebra 2 and Pre-Calculus. We're going to be talking about vertical asymptotes, and holes, and how to do limits at each of those things. Here we go. Let's say we have a function f of x equals 3 over x minus 2. Right away you should notice that we cannot plug in 2 into this function, because if we plug in 2 we get 3 divided by 0, and 3 divided by 0 is bad. Of course, I'm going to ask a question, blah. Haha. I'm going to say, well, x can't equal 2, but I can use a limit because this basically means that x is approaching 2, not equaling 2. And I'm going to ask you, what is the limit of 3 divided by x minus 2 as x approaches 2? And the way we're going to do this is we're going to look at a chart. So I'm going to go ahead and set up a quick chart. Here it goes. I picked some x values that, notice, are approaching 2, just like in the last section. And now all I'm going to do is plug in these x values into the function to get some y values. And here are the y values. Okay, so if we start picking numbers that are less than 2 here, we get negative 30, negative 300, negative 3,000. And then if we pick numbers that are greater than 2, we have 30, 300, and 3,000. Notice that I drew these in 2 separate colors. And the reason is, check out the trend. Negative 30, negative 300, negative 3,000. As x is approaching 2 on this side of 2, these numbers are approaching negative infinity, right? They're getting really, really big on the negative side, and if you continue plugging in numbers that are even closer to 2, you're going to get negative infinity. You're going to get larger negative numbers. Whereas if we approach 2 from the other side, from the right side of 2, then we get 30, 300, 3,000, and these are approaching positive infinity. Interesting. So what's going on here? Well, first of all, I have to tell you something, and that is that, hey, if you do this chart, this trend thing, and you get 2 separate numbers, 2 distinct numbers, or plus or minus infinity that are different, see how these are different, one's plus, one's minus, this limit does not exist. This limit does not exist. You might also see that written as non-existent limit. And that's because if you take the limit from the left and the limit from the right, and if they're not the same, then the limit can't exist, because the limit can only be one number. Now, I just said something, and it was something about the limit from the right and the limit from the left. What does that mean? Well, we want a way to write the fact that if you only look at the numbers on the left side of on the left side of 2, that they do go to something. And the way we're going to write that is like this. Limit, it's almost exactly the same. Limit x approaches 2 of 3 over x minus 2 equals, the limit is negative infinity. The way we're going to distinguish that it's coming from the left, from the smaller side of 2, is by putting a left right above the 2, a negative sign right there. Similarly, this limit was from the right of 2. So the way we write that is limit x approaches 2 from the plus side of 3 over x minus 2. And this limit equals positive infinity, like that. So the 2 one-sided limits still exist. They are positive and negative infinity. And yes, you can have a limit that is positive or negative or positive infinity. That's okay. Hey, let's take a look at the graph of this and see what it looks like and why this is happening. There's our fancy graph. You could have done this on your calculator if you want. Anyway, in red, in this red dot, I've drawn in that vertical asymptote, right? We have a vertical asymptote at x equals 2 because it makes the bottom 0. Should have remembered that. Anyway, and let's take a look at the limit from the left and the limit from the right. The limit on the left is over here because we're approaching 2 from the left side. So that's this over here. And we write limit x approaches 2 from the left of f of x. And then, just like before when we were looking at a graph, we're going to follow the y values as the x values get closer to 2. And you notice that the y values, they don't really get close to something. They just keep going down to negative infinity. Same thing on the right side. Check it out. Okay, these values are approaching 2 from the right, and so the y values are going up, 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 and away. So the limit as x approaches 2 on the right of f of x, this is going to be positive infinity. And because the left hand and right hand limits are different, the limit in general, nothing here, of f of x is dne, does not exist, or non-existent. Either is fine. Let's take a look at a different example, slight twist. So f of x equals 1 over x squared, and I'm going to ask, well, what's the limit as x approaches 0 of f of x? And if we look at a graph, we can tell pretty quickly what's going to happen. So here's a graph, and 1 over x squared, if you plug it into your calculator or remember, is going to look something like this, where you have that vertical asymptote at x equals 0, right there. And now take a look at the y values. As we approach 0 from the left, the y values go up, 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 up to positive infinity. That's fine. And then as we approach from the right, on the right side, the y values go up, 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 up to positive infinity. Look, these two things match. That's okay. Because they match, this limit in general is equal to positive infinity. And that's okay. So notice that you can have an infinite limit in general. There's no plus or minus here. That is equal to positive infinity. Great. Last thing I want to talk about is the difference between a vertical asymptote and a hole, and what limits do at each of these things. Every function can be written more or less as a top function divided by some bottom function. Notice that if it's just like a polynomial or f of x equals sine of x, then sometimes the bottom is just equal to 1. That's okay. But this is going to help us to distinguish between a vertical asymptote and a hole. Here's how we do it. We have a vertical asymptote if the bottom, wherever the bottom equals 0, and the top does not equal 0. And I'll explain why in a second. And then we have a hole wherever the bottom equals 0 and the top also equals 0 at the same time. As a general thing, this is true, mainly because they share a common factor and they'll cancel out. Let's take a look at some examples. Here's a schnazzy function, x squared plus 2x minus 8 divided by x squared minus 4. Just looking at it really quick, hey, there's going to be two values of x that give us 0 in the denominator. One of them is going to be positive 2, and if you think about it, the other one's going to be negative 2 because x squared equals 4 has those two solutions. Great. Now, what I'm going to do is I'm going to ask two questions. The first one is, what is the limit as x approaches 2 of f of x? And the other question is, what is the limit as x approaches negative 2 of f of x? Just to highlight the difference between these two things. Well, let's take a look at, I guess we could factor this. Hey, let's try factoring this down here. We're going to have the limit as x approaches, we're going to have f of x, we haven't done any limits yet. F of x equals, that top is going to factor into x plus 4 times x minus 2, and the bottom is going to factor into x plus 2, x minus 2. That's a difference of squares, and notice, shing, those two things cancel, right? And now because these two things cancel, this is a hole, okay? We have a hole at x equals 2. So let's go ahead and try to find that limit when x approaches 2. Because it's a hole, these two things go away. We no longer have the division by 0 problem, so we're going to just plug it into the rest. So the limit of f of x as x approaches 2 is just 2 plus 4 over 2 plus 2. 2 plus 4 is 6. 6 over 4 is 3 halves. Great. Hey, guess what? A hole has an x and a y coordinate, so the coordinates of the hole are the x value, which was 2, and the y value which we got from that limit, which is 3/2. Awesome. Next, we have to do the limit as x approaches -2. Notice that that's this part, and if we plug in -2 into the top, we get something that is not 0. That means -2 is going to be our vertical asymptote. And if we graph this function, I'll do it on the next slide. Here's what happens when I graph this function. It looks like this. We can see two things. First off, the limit as x approaches 2, that was our whole, and we can see that very clearly the y values are approaching some set y value when we figured out that the y value was 3/2. Whereas if we approach -2, notice that we have this asymptotic behavior, and on the right side the function is going all the way up to +infinity, and on the left side the function is going all the way down to -infinity. And so we can say that the limit as x approaches -2 in general, the general limit from both sides, this does not exist because the left hand and the right hand limits don't agree with each other. So that's how to do that problem. Enjoy.